Hello students, I'm happy to welcome you all for the new academic year 2020 to 2021. We are entering into the new beginning, so first of all let me introduce myself to you. My name is TJ Suraj, PG Assistant in Physics, Don Bosco MATRIC ISND School, Tirunelveli. In 12th standard physics, the first lesson is electrostatics, which deals with electrostatic force. So, what is electrostatic force? So, in 11th standard, you have studied many forces like gravitational force, frictional force, and tensional normal forces, like that. So many other forces you have studied. So out of these the forces, so except the gravitational force, the remaining all the forces are arises due to the electromagnetic force. So then what is electromagnetic force and what is electrostatic force? So let us see, right? So now I will give you one small example, right? So when we stand on the earth's surface, the gravitational force on us acts downwards and the normal force acts upwards, right? So this is you have studied in 11th standard, right? Have you ever raised the question where this the normal force comes from, right? So now I will tell you. So where this the normal force comes from. So this is arises due to the electromagnetic interaction of atoms on the surface of the earth with the atoms present in the feet of the person, right? But it is due to the electromagnetic force of attractions. Now I am coming to the point, right? So our topic it is electrostatistics. So this the topic I can divide into the two words, right? Electro and statistics. So the word electro which represent a charges, and you know the literal meaning of static, right? The static means it is rest. But then the charges is at the rest, right? So this chapter that we are going to study about the electrostatic forces, which means, right, the charges are is rest, right? So now I wanted to tell you the two important points. When the charges are at rest, it shows the electric property. When the charges are in motion, it shows the magnetic property, right? About the charges is at rest, right? It shows the electric property. So this chapter it is deals with the charges is at the rest. So I will give you the definition. So the branch of electricity which is deals with a stationary charges is called electrostatistics. Students, today we are going to discuss about this topic, right? Frictional electricity, and what are the basic properties of electric charges, and what is Coulomb's law and Coulomb's law in vector form, and what are the units of charges, right? So in SI system we have the units, in CGS systems, right? So we are going to discuss about the units of charges and what is permittivity and what is relative permittivity, right? And continuous charge distribution. So these are the topics that today we are going to discuss, right? So first we will see the frictional electricity. So this phenomena you have come across in your day-to-day life, right? So let us I can give you a small example. So while after combing your hair, right, after combing your hair, if you place the comb near the small bits of paper that you have observed, right, the comb, it is get attracted the small the bits of papers, right. And I will give you the another example. After ironing your silk cloth, which means silk shirts or any other clothes, right, after ironing, if you place near your hand near the silk cloth, you have observed that your body hair will attracted towards the silk cloth. So this is the phenomena that you have observed in your day-to-day life. And have you ever think why these are happening, right? So this is happening due to the electrostatic forces or the force of attraction between the charges, right? But then where these the charges are comes from? So these charges are comes from due to the friction, right? So the frictional electricity is the electricity produced by rubbing two suitable bodies and transfer of electrons from one body to another. So due to the friction, the electrons it is transferred, right, from one body to another body, right. So if the one body loses the electrons, so that body there will be excess of positive charge, so it makes the body become positive, right. So here I have given the another two situations, right. So one, it is a glass rod is rubbed with a silk cloth. So due to the friction, right, so you have observed the glass rod which is occurs positive charge, and the silk cloth it is occurs negative charges, right. And I will give you the another situation, right. The ebonite rod it is rubbed with a flannel, right, or you can say it is a fur cloth which is animal fur. So it is rubbed, right, when the ebonite rod it is rubbed with a fur cloth. So the same thing, right. So but here the ebonite rod it is occurs a negative charges, and the fur cloth which is observe a positive charges. So both the things it is happening, it is due to the frictional electricity, right. But then why the glass rod it is absorb positive charge and the ebonite rod it is occurs the negative charges? So in the first situation, the electrons in the glass are loosely bounded. So when you rubbed with the silk cloth, the loosely bound electron in the glass rod it get transferred to the silk cloth. So there will be the excess of electrons in the silk cloth. So this makes, or as the result, the silk cloth it occurs a negative charges and makes the silk cloth will be there will be the excess of electrons, and the glass rod which loses the electrons, so that this makes the glass rod positive, right. So here as the result the glass rod became positively charged and the silk cloth becomes negatively charged, right. So in the second case, so the electrons in the fur are loosely bound in it than the electrons in the ebonite. So when the ebonite rod and the fur are rubbed together, comparatively the loosely bound electrons from fur get they transferred to the ebonite. So as the result the ebonite becomes a negatively charged and the fur becomes a positively charged, right. So here keep in mind, so here the electrons it is get transferred, not producing, so that we are not producing any charges, right. So here actually the charges are transferred from one body to another body. We are not producing any charges. So these charges already in the bodies. You know that all the bodies are mostly, it will be the electrically neutral. When the bodies are lost the electrons, the body it is become positive, right? When the body it gains the electrons, it is become negative body, right? So here actually keep in mind, actually the electrons are, it is transferred from one body to another body. So if the electrons are transferred from a body, then the deficiency of electrons makes the body positive. If the electrons gained by the body, then the excess of electrons makes the body negative, right? So here I have given some of the examples. It rubbed with the two bodies, it is rubbed with the due to the friction. So which body will occur positive and which body will occur a negative charges, right? So here first column, so I have given a glass rod, right? It is rubbed with silk cloth, right? So when the glass rod it is rubbed with a silk cloth, the glass rod it occurs a positive charges, and the silk cloth it is occurs a negative charges, right? And the second one, the amber. So amber, I think it is will be a new word to you, right? So amber, so this amber it is nothing but it is a solid, a translucent material, right? Amber it is a solid, a translucent material formed from the resin of the fossilized tree, right? And the ebonite, rubber, plastic. So these are the materials which is rubbed with a woolen cloth or a animal fur. So when you rub these materials, the wool or the fur cloth, it is occurs a positive charge. The amber, ebonite, rubber, plastic, which is occur a negative charges, right? And the last one, the ebonite rod, it is rubbed with a polythene, right? So rubbed with a polythene. The polythene it is occurs negative charge, and the ebonite rod is positive charge, right? And another, the last one, it is a dry hair. So this is the example I have given. So in when you comb your dry hair, the comb it is occur a positive, negative charge, and the dry hair it is occur positive charge. Okay, now we will move on to the next topic. So now we will see some basic properties of charges. What are the basic properties of the charges? The first ones, as we know that there is two types of charges, right? So that is a positive and a negative charges. So these positive charges will nothing but it will implies the protons, right? And the negative charges which implies electrons. So you have studied, right? So the proton carries the positive charge and electron carries the negative charge. So we have the types of charges, positive and negative charges, right? And here the like charges are repel each other, and unlike charges are attract each other. So like charges means the two charges, right? So two positive charges are two negative charges, right? If you place the two positive charges near it, so they will repel each other, or if you place two negative charges near it, so it will repel each other. So unlike charges are attract each other, right? So unlike charges means one of the charges may be positive and another charges will be negative, so they can attract each other. So these are the another property. And the charge is a scalar quantity. Charge is a scalar quantity. So you know that what is a scalar quantity. So you have 11th standard itself, so you have studied, right? The scalar means it has only the magnitude, right? and vector mean it has a magnitude and direction, right? So here the charge is a scalar quantity, which means it has only the a magnitude. So whether it is a positive or a negative charges, right? So the value of charges, we can take only the magnitude alone, right? In your lower class itself, so you have studied the proton carries a positive charge and the electron carries a negative charge with the magnitude of 1.6 into 10 power minus 19 coulomb, right? That coulomb, it is the unit of charges in SI system. That keep in mind, right? In SI system, the unit of charge, it is coulomb, right? And the charges, it is always additive nature, right? Additive nature. So for example, in a system, it carries one side, it carries a positive plus 2 coulomb, and another side you have a plus 5 coulomb, and another side you have a negative charge, which is minus 3 coulomb. So the net charge of the system, it is equal to plus 4 coulomb, which means a 2 plus 5, 7 minus 3, which is the net charge, it is equal to plus 4 coulomb. But the charges, it is additive in nature, and also the charges is quantized, right? Which means if the electric charges exist in discrete packets rather than in continuous amount, right? So for example, it can be integral multiple. Quantized means it is the integral multiple, right? So simply that we can give the expression that is which is Q equal to n times of E, n times of E. So if we have a plus 5q, which means a 5 times of a charge of an 1 electron, that is Q equal to n times of E, where n represent the 5 and E represent the a charge of an electron. That charge of an electron, which is equal to 1.6 into 10 power minus 19 coulomb, right? So you can calculate, right? So this is the relation, right? So Q equal to a plus or minus n times of V, and n, it is the number, it is 1, 2, 3 and so on. So you can calculate the net charge from this equation. So keep in mind, so this is an important equation, that Q equal to a plus or minus n times of E. And the another point, the charge, it is conserved, right? So conservation. So in your lower class you have studied energy conservation. As you know that energy neither be created nor destroyed. It can be transferred from one system to another system. So like as here, the charges is also a conserved, which means I already said the charges are not producing, right? It can be transferred. But then here we can say the charges is neither be created nor destroyed. It can be a transfer from one system to another system, right? So the algebraic sum of the positive and negative charges in an isolated system remains constant, right? So already we have seen the one discussion, right? So when the glass rod is rubbed with a silk cloth, the glass rod, it occurs positive charge, and the silk cloth, it occurs a negative charges, right? So here the negative charge appears on the silk, and then the equal amount of positive charge appear on the glass rod. So the net charge on the glass silk system remains 0 before and after rubbing. So before rubbing, so both the body will be in neutral, which means the glass rod, it is in neutral, which means equal number of positive and equal number of negative charges, and silk cloth also equal number of positive and a negative charges. So after rubbing, right, so there is a reorientation of the electric charges. There is a transformation of the electrons from a one body to another body. The glass rod became positive and the silk cloth become a negative. So by the charges are additive in nature, so the charge of the isolated system, it is equal. So the charges is conserved, right, and it does not change with the velocity also, right. So whether you are rubbing with very fast or slowly, whatever it may be, so there will be the transformation of a charges. So it does not change with the velocity also, right. So let us, we can move on to the next topic, that is the Coulomb's law. It is otherwise it is called Coulomb's inverse square law. So this the law which tells about the force between the two point charges, right. So by the definition, the electrostatic force of attraction, so it is said to be the interaction, which means attraction or repulsion between the 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, and acts along the joining the two charges. And keep in mind, while writing the Coulomb's law, so most of the students, they can commit the mistakes, they can leave off the word. So they will return, right, the force of attraction between attraction or repulsion between the two charges is directly proportional to the charges, right. So that is not correct. So since it is a law, so you have to write as it is, right. The definition question, if you write by your own means, there will be no wrong in it, right. But in laws, you have to write as it is. So while writing this Coulomb's law, so keep in mind, so it is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. In some of the students, they will write square root, right. Okay, so you can keep in mind, right. So it is a square of the distance between them, right. So here, so and the Coulomb's law, it is applicable only on the stationary point charges, right. So here I have taken two stationary point charges. One of the charge, it is Q1, and another charge, it is Q2, and these two charges are separated by the distance, it is r, right. So by the definition, I can write the F is directly proportional to the product of the two charges. So F is directly proportional to Q1 into Q2, and the second point, it is inversely proportional to the square of the distance between them, right. So as it is, we can write, right. So F is directly proportional to Q1 Q2 by R squared. So we have to give a proportional constant, right. So that proportional constant, it is K. So where K, it is a positive constant, right. Keep in mind, the K, it is always a positive constant, or electrostatic force constant, or it is said to be a Coulomb's constant, right. So that the value of K, it is 1 by 4 pi epsilon naught, right. 1 by 4 pi epsilon naught, it is in vacuum, right, which means if the charges are placed in a free space or in vacuum, the same charges may be in some of the medium, which means that these charges may be present in oil, right, or water, in any other mediums, right. So there the proportional constant, it is different, but here now we are seeing in vacuum, right. In vacuum, that the proportional constant, that K, positive constant value K, equal to 1 by 4 pi epsilon naught, right. So this symbol, it is called, right, the symbol it is called epsilon naught. That epsilon naught, it is nothing but it is the permittivity of free space. Permittivity of free space. So permittivity, what is meant by the permittivity? In electromagnetism, the permittivity of free space, which means the ability of the medium or the capability of the medium which allows the passage of electric lines of force. I repeat, right? In electromagnetism, the permittivity of a free space, which means the ability or the capability of the vacuum. In case if it is in vacuum, you can use the word vacuum. In case if it is in medium, you can replace the vacuum into medium, right? So the ability or the capability of vacuum which allows the passage of electric lines of forces, right? The same things I already told you in medium. So we can write the proportional constant, that k equal to 1 by 4 pi epsilon. So there in vacuum, that we have to write it is epsilon naught, but here it is epsilon, right? So that epsilon, it is the permittivity of the medium, right? So now we will move on to the another one, so which is relating, right? So both we are relating the permittivity of free space and the permittivity of the medium. That will use the relative permittivity. Relative permittivity or dielectric constant or specific inductive capacity or dielectric coefficient, right? So we have the many names, so keep in mind dielectric constant, right? Relative permittivity, specific inductive capacity or dielectric coefficient, right? It is given by capital K. It is small k, right? It is a capital K, and usually we will represent as epsilon r. Epsilon r means relative permittivity. It is nothing but it is the ratio between the permittivity of the medium to the permittivity of the free space. Permittivity of the medium, it is the ratio between permittivity of the medium to the permittivity of a free space. That is epsilon r equal to epsilon by epsilon. Okay, in Coulomb's law, if the charges are present in vacuum, can be written as F equal to 1 by 4 pi epsilon naught q1 q2 by r square, right? In case if the charges are present in medium, that equation can be written as F equal to 1 by 4 pi epsilon, right? 1 by 4 pi epsilon q1 q2 by r square, right? So these epsilon can be replaced, which means that epsilon from this equation, epsilon equal to, you can cross multiply this, right? So epsilon equal to epsilon naught epsilon r. So that can be written here, that is epsilon naught epsilon r. So F equal to 1 by 4 pi epsilon naught times of epsilon r into q1 q2 by r square, right? So these are the two equation, Coulomb's law equation in vacuum as well as in medium, right? So here the permittivity of free space, right? The permittivity of free space value, so keep in mind, so sometimes these the value, it may be given in exam or may not be given, so you have to memorize these the value, right? So epsilon naught value, which is equal to 8.8542 into 10 power minus 12. So mostly the students make a common mistakes whether it is a minus 12 or plus 12, so they will get confused in exams, right? So keep in mind it is a into 10 power minus 12, and the unit it is, right, Coulomb square, Newton minus 1 and meter minus 2, right? So this is the unit, right? This is the unit the unit of permittivity of free space, whether it is permittivity of free space or permittivity of the medium, right? So whatever it is, that unit is Coulomb square per Newton meter square. So then students, tell me, what is the unit of epsilon r? So the relative permittivity has no unit. Why it is no unit? Can you guess? Yes, exactly. So it is the ratio between the same quantity, right? It is the ratio between the same quantity, right? So it is epsilon by epsilon naught. So both will have the same unit, so they can cancel each other. So epsilon r, the unit of epsilon r, the unit of dielectric constant, the unit of relative permittivity has no unit. So this is all, this will be a one word questions will come, right? And another important one, so that 1 by 4 pi epsilon naught value, right? 1 by 4 pi epsilon naught value. So don't confuse with epsilon naught value and 1 by 4 pi epsilon naught value. So that 1 by 4 pi epsilon naught value, which is equal to 8.9875 into 10 power 9 plus 9, right? Newton meter square per Coulomb square. So exactly it will be opposite to this. Here Coulomb square, here it is Coulomb minus 2 and Newton minus 1. So here it is Newton, right? So meter minus 2 and here meter square. So it is exactly opposite because it is 1 by 4 pi epsilon naught value. So this will be, we can round off these values, right? So we can round off this value, which is equal to 9 into 10 power 9 Newton meter square per Coulomb square, right? So these are the values you have to memorize. One value, it is epsilon naught value, which is 8.8542 into 10 power minus 12 Coulomb square per Newton meter square, and another value 1 by 4 pi epsilon naught, which is equal to 9 into 10 power 9 Newton meter square per Coulomb square. So now I wanted to add one more point, this epsilon r value, right? This epsilon r value, which is the relative permittivity for free space or vacuum, which is always equal to 1. This is also one word question will come. What is the relative permittivity of free space? What is the relative permittivity of free space, or what is the dielectric constant for the free space? It is always equal to 1, right? For any other medium, the relative permittivity value, it will be greater than 1. I repeat, because here I have not given that points, right? So that I can repeat that epsilon r value, which is the relative permittivity of free space or vacuum, is equal to 1. For any other medium, the dielectric constant is greater than 1.